FURC attendees. My name is Shannon O'Connor, and I'm going to be talking to you a little bit about our poster for Electrospray applications and development of Electrospray. I'm with Embry Riddle Aeronautical University in Daytona Beach, and I'm on a team with Sahil Ghate, John Veracka, Professor Madiyar, Professor Kim, as well as Mounisha Ganesan. Sahil Ghate is our PI, and we've been working closely together for the past 2 years on this project. A lot of the information that you're going to see on the poster is our first developments of what we did last year with experimentation, but largely trying to build our own Electrospray setup. A quick background of what Electrospray is, for those who aren't familiar, Electrospray is a application process of sort of like, imagine if you have a spray gun or a spray paint and how you apply it to different surfaces. Same idea, but different method. So the Electrospray gun works as in you have a needle tip that is charged, attached to your solution. It works as almost like a syringe that it'll then be expressed out of, and then you have your substrate of sorts. Now, the special part about Electrospray is between the needle tip and the surface that I'm spraying, I'm running a electric field that will not only pull the solution material to the surface of what I'm wanting to coat, but it also shreds apart the solution droplets that exit the needle tip to tiny, tiny pieces due to the Rayleigh limit, which allows only a certain amount of charge to be on the surface of each drop. And when you overcome that limit, so to speak, the drop forces itself to kind of shred into smaller droplets, so it has more surface area and it can hold the amount of charge that you're forcing it underneath in such conditions. This is a really good spray technology or spray type because it is advantageous to use with expensive solution types. We've been working largely with carbon nanotube solutions, which are incredibly expensive. And we're hoping to find that the Electrospray can be a good solution to being able to use efficiently and effectively really expensive solutions like carbon nanotubes to be able to apply it to large surfaces and use it industrially on a larger scale. Now, why we're using the carbon nanotube solutions is that later in our project that we're hoping to get smooth surfaces of carbon nanotube solutions over across different kinds of substrates. Right now we're using glass slides, let that dry, and then we can run currents throughout to see if they will heat up and act as a sort of de-icing technology to the aerospace industry, similarly to how the back windows of your car, when you run the defroster through them, the lines running across your back windows will heat up and slowly defrost your back windows that way. But imagine instead of having those lines, you just have one giant sheet of warming material across your surface. And so that's what we've been working on with Electrospray. Within the poster, you'll find some of our results on Taylor cone formation, which is the important part. That's when you start getting that misty spray that you need or that you're hoping to achieve through Electrospray. And this coming semester, our future work will involve working with a professional setup of Electrospray equipment instead of us having to construct our own, which proved to be really difficult last year. And hopefully with this, we'll be able to do a lot more testing and get further results for the kind of information that we're looking for. Thank you for your time, and we hope you enjoy the rest of the FURC conference. And a quick shout out to the folks at the Undergraduate Office of Research. Thank you guys so much for your support and for the funding, and we look forward to continuing this research into the future. Have a great day.